Okay, on number 2 and number 3, what I thought you might need help with is actually drawing the pictures, because this time we just have some word explanations that describe the circuit to us, and we have to come up with a schematic for the original circuit that makes sense given the parameters. So it says that we have a 12, a 10, and a 15 ohm resistor that are connected in parallel. So maybe you would draw a picture something like this. So I have a 12, a 10, and a 15. So 12, 10, 15. And this parallel combination is in series with a 6 and an 8. So I could then do something like this. This now is in series with a 6 and an 8. And my battery is 36 volts. 36 volts. So that works. But now I'm going to draw a different picture. So I might do something like this. This is going to look kind of similar to the one that we just had. I'm just going to orientate it a little bit differently. So I could have the 12, the 10, and the 15. So 12, 10, and the 15 that are in series with a 6 and an 8. Maybe that's a little bit easier for you to see. I don't know. And then I'm going to pick, so they didn't really tell us, so I'm just going to pick my orientation of my battery to be going like this. And then let me do one more. So probably a more common way to draw something like this might look more like this. So I'm going to have 1, 2, 3. So we're going to have the 12, the 10, and the 15. So let me write those in. And then they are in series with the 6 and the 8. And I'll make my battery look something like this. So my point is that there are more than one way to draw a picture that should give us the exact same answer no matter how we analyze that circuit. But let's pretend that this was our original circuit. So if I ask you to do this and to find the equivalent resistance, this is my guess what you would do. You'd say, oh, all of these guys are in parallel, 1 over 12 plus 1 over 10 plus 1 over 15, and then 1 over it, and you would replace that with an REQ. And so then your next picture that you draw, you'd have your battery of 36 volts. You'd have your 6 there. You'd have your 8 there. And you would have taken that parallel combination and you would have replaced it with an REQ of whatever its value is. So you can see that that REQ then is in series with the 6 and the 8, which is how I know that it meets the parameters. All right, let's look at the second circuit. So the second circuit down here says that we have a 7, 1, and a 10 that are in series. So if something's in series, it means it has no choices but to go through all of them. So I'm just going to draw them on the same line or the same path. So a 7, a 1, and a 10. This series combination is then in parallel with a 6. So I'm going to make it in parallel with a 6. There's a 6. The combination of the 4 resistors is then in series with a 10.3. So I could do something like this, and I could put a 10.3 right there and a 20 volt battery. So that would meet the constraints. I could do something like that. Let me do it a different way. So I could have the 7, the 1, and the 10 that are in parallel with the 6. And then this combination of 4 would be in series with the 10.3, and I could put my battery like this. So let's just look at this picture for a minute, because sometimes it's not as easy to see that as it is to maybe see this. But if you were going to do the REQ of this, my guess, or the equivalent resistance, my guess is that you would choose to combine this first. And so we would have a 7, a 1, and then a 10. So we would end up replacing that. I'm going to actually go against convention and put it over here. I would keep my 6. I would replace those 3, the 7, 1, and the 10, with an REQ. So that REQ, we can just add those up. That would be, what, 18. And then I would have my 10.3 over here. And then I think the next step that you would do is you'd combine those two, which is why they said that this combination, or this REQ value, then is in series with the 10.3, and then you could continue on down and to analyze your circuit that way. So again, I'm purposely choosing to not finish this. I want you to have a chance to try to do a calculate carry back and to see if you get those answers. Give it a good shot, and if you end up with a disaster, you can contact me and I can help you go a little bit further, maybe with a one-on-one. And it's also okay to turn in your homework assignment, even if it's not 100% correct. Okay, let's see what you can do with those.